A random sampling of 16 students was selected from the student body at a local college to determine the average amount of money that students carry with them. If the sample mean x bar was equal to $28 with a sample standard deviation of s equals 6, then construct a 95% confidence interval for estimating the mean amount of money all students carry on them. So if you take a step back and remember, the purpose of building a confidence interval is to use sample information to estimate something about the population. In this case, we are estimating the population mean amount of money all students, the whole population, carry on them. And we're using our sample information from these 16 students to make that estimate. So since we have a sample standard deviation, this problem calls for a t-distribution, not z-scores, but t-scores. So notice that the formula has a sample standard deviation here, and it also has the t-scores instead of z-scores. So it is x bar minus t 97.5 times the standard deviation divided by the square root of the sample size, and the rest of the formula, it's the same thing on the other side except there's an addition instead of a subtraction. So this t 97.5 is necessary for building a 95% confidence interval because if you remember the picture right here, when you are building a 90% confidence interval and you cut off the center 90% of the curve, the symmetrical bell curve, you have 5% of area left in the left tail. So this t-score right here is labeled t 95% because there is 95% of area to its left. 90 plus 5. So where are we? Here we go. So that's why we're using t 97.5% in our formula. So to find out what this t-score should be when we plug in our numbers, we go to our calculator, we use INVT, and for the area we put in 0.975 and we put in 16 minus 1 degrees of freedom because the DF is n minus 1. So let's go to our calculator and we're going to just demonstrate how to get the answer for that using INVT. Let my calculator start up. Okay, second DISTR, INVT is number 4. 0.975 for a 95% confidence interval. That's what we're building. And a sample size of 16 means the DF will be 15. Okay, paste. 2.13. And that's where our t-score comes from, and that will be the t-score that we are going to use in our formula. So now we can put the rest of our numbers into the formula and plug them in to get an answer. We have a mean of 28, a t-score of 2.13, the sample standard deviation is 6, the sample size is 16, it is not 15, the sample size is still 16. So plugging those numbers in, 28 minus 2.13 times 6 divided by the square root of 16, and 28 plus 2.13 times 6 divided by the square root of 16. So we could go to the calculator and plug this in and make sure we can get the same answer that we got there. 28 minus 2.13 times 6 divided by the square root of 16 is 4. You could just enter a 4 there if you want, but in other numbers it won't be as clean. In other problems, sorry, it won't be as clean. So we can just practice using our square root symbol and putting in 16 there. So 24.81, we're going to round to 2 decimal places, and let's change this minus to a plus. We're going to repeat that previous problem. scroll over, change it to a plus, and 31.20. 24.81 to 31.20. Okay, and that is what we have here. So to interpret this, we're going to use that standard approach that we used in the previous lecture. We are 95% confident that the true population mean amount of money students carry with them is from $24.81, $24.81 to $31.20. And if you need to find the margin of error, it's the same approach that we saw in the last lecture. We're going to take the upper limit of the confidence interval minus the lower limit and divide it by 2. So 31.20 minus 24.81 and divide it by 2, and that's $3.20. I will demonstrate that because it's very important that you put those in parentheses on your calculator. 31.20 if you need you don't have to put the 0 here if you don't want to. It's just there to demonstrate the dollars and cents. And okay, so here's the correct way to do it with parentheses around the numerator. 3.195, which rounds to 3.20. If you remove the parentheses, you're going to get a different answer, the wrong answer. So make sure you put parentheses around the numerator when calculating the margin of error. Okay, so to build a 99% confidence interval, you only need to change the t-score. So you go to INVT on your calculator, but this time the area that you're going to be using is 0.995 with 15 degrees of freedom, because you're changing your t-score, you change the confidence interval, you change the t-score. So we'll go to our calculator and INVT with 0.995, keep the degrees of freedom at 15. $2.95. Let's come here. Okay, plugging in the rest of our numbers that we had from before. We're just changing the t-score to 2.95. Now when we increase our confidence level, we are going to be widening the actual interval, because when we increase the confidence level, we have to make our lower limit lower and our upper limit higher to cover more possible sample means. So let us plug that in now. 28 minus 2.95 times 6 divided by the square root of 16. Okay, so we have in this case 23.58 oops. And 32.42. Looks like I have a slightly different answer. Oh, 32.43, because the 5 here bumps this 2 up to a 3. So 23.58, 32.43. And that is our answer. So to interpret that, now we are 99% confident that the true population mean amount of money students carry with them is from $23.58 to $32.43. So the confidence interval widened when the confidence level increased. The margin of error is also going to increase with this increased confidence level. We take 32.43 minus 23.58 and divide it by 2, and the answer is $4.43. Make sure you have your parentheses around the numerator there.